Hi students, I am Suraj Prasad and I am a BTech graduate from IIT Patna and working in Ask IIT for the past 2 years as a chemistry faculty. Today I am going to teach you the topic of carbon and its compounds. In this chapter, I'll tell you what are the most important stuffs which is required to know, because that is the minimum requisite for you, which will be helping you out in the further higher classes. So you must have a great command on those things. Now when I say carbon, when I say carbon, like for example right now you are in class 10th, when you start class 11th, 12th, then you will have a different subject or let's say sub-subject of chemistry subject. So that is organic chemistry. Now carbon, it is only a simple non-metal, but what is that property which has made a different topic or a whole book on carbon and its compounds? Organic chemistry, it totally deals with carbon and its compounds, like carbon with hydrogen and oxygen, all those stuffs compounds. So what is so special with this carbon? इस कार्बन में ऐसा क्या स्पेशल है जिसकी वजह से it has introduced a new book in your syllabus, okay, when you will be entering in the higher classes. That thing I am going to tell you, and that also on a clear note. Okay, you should not have any doubt in it, because अगर अभी कोई doubt बच जाता है mind में, then you will have a lot of problem in the higher classes. So it's better to settle down all your doubts and have a clear mind, and then only you learn organic chemistry with full energy and confidence. So first of all, I would like to tell you some facts which you must know, that what carbon derived from, the word carbon. So it actually derived from a Latin word which is known as carbo. And the meaning of carbo is coal. So basically, when I say carbon, it was actually found from coal in the earth crust. And you will be you will be totally surprised to know that in the earth crust, if I talk of the percentage of the non-metal carbon, okay, then it is only 0.02 percentage in the earth crust, and in the earth atmosphere it is only 0.03 percentage in earth atmosphere. See the data, it's very small quantity. With this small quantity, can you imagine that a new book will be introduced in your chemistry subject in the higher classes? That's so strange. कितना इसका percentage इतना low है, then also you have to study a separate topic, separate book for organic chemistry, right? So it's totally uncertain. Now why you have to study a separate book for organic chemistry in the further higher classes, or in class 10th also? In your class 10th also you have to study organic chemistry a bit. So why is that thing? And the answer to that is it's not about the percentage present in earth atmosphere or the earth crust, sorry. So it's basically about the abundancy in applications. एप्लीकेशन से क्या मतलब है? एप्लीकेशन से आई एम ट्राइंग टू से दैट द ह्यूज यूसेज of the element carbon in different compounds. For example, if I take, let's say, petrol, if I, let's say, take LPG, the cooking gas which your mothers use to prepare your food, prepare food, or we can say plastics, plastics, buckets, even your pencil, it has a allotrope of carbon, if you know, that is known as, someone said graphite, and you are very correct, that is known as graphite, and that is a allotrope, that is a form of carbon, okay, allotropic form of carbon. Then there are various applications like tires, rubbers, clothes which we wear, clothes, and it is also used in the jewelry like diamond, diamond. So diamond is also one of the allotropic form of carbon. So these graphite and diamond, they are the allotropic form of carbon. And not only this is just a small subset. I am saying, I am only saying this is a small subset. ये बहुत छोटा सा एक पार्ट है which I have given in the form of examples. Carbon has got a wide applications. Soaps and detergents, all the petroleum products, so they all have carbon in it. And this property has made you guys to learn organic chemistry, separate book. Okay, in higher classes, in your class 10, it is included, okay, in the science syllabus only. So you have a subset to read of organic chemistry. Now, next thing is, in this lecture, I'll be not dealing with all the organic compounds, but I am interested in telling you about the allotropes. Okay, all the allotropic form of carbon. Allotropes के बारे में हम लोग पढ़ेंगे, and it is very very important for you guys to know about it, that what kind of structure they have, what is the theory associated with it, what makes it to show that kind of property. There's properties like, for example, diamond, it shines a lot, है ना? Graphite, it is lubricant, it is used as lubricant. So these all properties, what is the basic funda or the logic, that I will tell you. वो अगर तुम लोगों ने एक बार पढ़ लिया, एक बार अगर माइंड में, if you have got the funda, then you will never have any doubt in understanding the properties of any of the carbon compound. So बहुत ध्यान से सुनना उस चीज को, try to listen it very very carefully. It's very very important for you. Now when I say allotropic form, then I am basically dealing with two types. One is crystalline form and another is amorphous form. Crystalline and amorphous form, and in this small video lecture I am going to tell you about crystalline, okay, crystalline form of crystalline allotropic form of carbon, which will be used in higher classes also, which will be reading in higher classes also. So this crystalline form, it is subdivided into like diamond, it is a crystalline form, graphite, that is a crystalline form, and Buckminster Fullerene, okay, Buckminster Fullerene. So they are all the crystalline forms of carbon. Crystalline form carbon means allotropic crystalline form of carbon. Okay. And if I talk for amorphous, then amorphous में क्या आता है? It is my coal, it is my coal, it is my charcoal. It is lamp black. Lamp black use करते हो ना? काजल लगाते हैं आईज में, राइट? सो दैट इज लैम्प ब्लैक ओनली, राइट? दैट इज लैम्प ब्लैक ओनली. Some guys they say kajal, some guys they say nazar battu. Yeah, those all stuff. So that is your, so they are your amorphous form. And crystalline form is your diamond, graphite, Buckminster fullerene. Now there are many series of Buckminster fullerenes also. Okay, earlier we were having only C60. Now we have C70 also, C80 also. So this part I am going to tell you in this small video lecture, that how, why, and what is that thing which is there in the diamond or in the graphite, due to which they show that kind of property. Okay. Now, if I talk for diamond, अगर मैं डायमंड की बात कर रहा हूं, देन फर्स्ट ऑफ ऑल you should know the properties, okay, of diamond. Diamond is the hardest substance known. It is the hardest substance known on earth, guys. इससे ज्यादा हार्ड आज तक कुछ हुआ ही नहीं है. The scientists, they or the researchers, they are developing or they are trying to find it out, but अभी तक उनको कुछ मिला नहीं है. So till now, till date, diamond is the hardest substance known. Hardest substance known. Then next property is it shines a lot. It shines a lot. A lot. अच्छा, अगर तुम लोगों ने फिजिक्स में कभी टोटल इंटरनल रिफ्लेक्शन पढ़ा हो, सो तुम्हें पता होगा TIR, टोटल इंटरनल रिफ्लेक्शन. दिस थिंग इफ यू हैव रेड अक्रॉस एनीवेयर इन योर सिलेबस इन फिजिक्स, देन दिस अ प्रॉपर्टी दैट व्हेनेवर योर लाइट, इफ इट इज ट्रेवलिंग फ्रॉम अ डेंसर मीडियम टू माई रेयर मीडियम, and the angle of incidence, okay, angle of incidence is greater than my angle of critical angle. If my angle of incidence at any moment in the denser medium is more than my critical angle, then my light will not refract. Okay, there will be no refraction, there will be only reflection. There will be only reflection, and that is what we say total internal reflection, right? Total internal reflection. For example, I take a glass slab, एक मैं glass slab उठा लेता हूँ, and this is my normal, and let's say this is my eye, okay, initial angle. You must be knowing, guys, that whenever light travels from a denser medium to rarer medium, then it moves away from the normal. So suppose this was the assumed path, but it will move away from the normal. It will be like this, है ना? This is the first case. This is the case 1. Next thing is, when you have a light and its angle of incidence is equal to critical angle, here I, that is equal to C, here I was less than C, okay? So this will go like this, this will go like this at the edge of the glass slab, at the edge of the glass slab. Now what comes the third case? What comes the third case? So in the third case, my eye, that will be greater than my critical angle. जिनको नहीं पता है टोटल इंटरनल रिफ्लेक्शन, उनके लिए मैं ये रिवाइज करवा रहा हूं फिजिक्स वाला पार्ट. Now when my eye angle of incidence, this is my more than critical angle, then what happens? फिर कोई रिफ्रैक्शन नहीं होता है. Then there is no refraction. My light never goes refraction. Instead, it goes reflect inside the slab only. and it will follow the laws of reflection also. It will follow the laws of reflection also. मतलब angle I, this should be same as this angle. Okay, angle R. This is now the angle of reflection. This is the angle of reflection. So this property is known as total internal reflection, TIR. Total internal reflection. इस property को क्या बोलते हैं? When light it do not undergo refraction, but after providing some critical angle, more than critical angle, then your light all reflect inside the denser medium itself. That thing I say total internal reflection, and in this way my light never moves away, never goes away. Now similar thing happens with the case of diamond. Why did I tell you about total internal reflection? Because similar thing is happening in diamond also. In diamond, the structure, or let's say the shape of crystal, that shape of crystal is cut in a particular angle. Okay, it is cut in some particular angle, और वो एंगल ऐसा कट होता है, उसका शेप मतलब इस टाइप का है. लाइक सपोज मैं यहाँ पे ऐसा कुछ क्रिस्टल ड्रॉ कर देता हूँ. ओके, सपोज दिस इज डायमंड. सो द एंगल एट विच दिस डायमंड हैज बीन कट इज लाइक, इसमें जो भी लाइट एंटर हो रही है, ओके, इसमें जो भी लाइट एंटर हो रही है, after entering the light inside the diamond crystal, when the light tries to go outside, it is not able to go outside. It is not able to go outside because of the shape of the diamond has been cut like that way, that if a light enters it, it will be, the critical angle will be like, my angle of incidence will always be greater than the critical angle. Okay, इसको ऐसे काटा गया है कि इसमें एक बार अगर लाइट चली गई तो वो लाइट अगर दोबारा अंदर से बाहर जा रही है तो वो बाहर नहीं जा पाएगी, वो सब की सब लाइट अंदर ही चली जाती है. बिकॉज द एंगल ऑफ इंसिडेंस देयर इज ऑलवेज ग्रेटर देन माई क्रिटिकल एंगल, एंड दैट इज द रीजन, बिकॉज ऑफ दिस मल्टीपल रिफ्लेक्शंस इनसाइड, multiple reflection inside, diamond shines. Okay, because of the multiple total internal reflections, you can say. Okay, multiple TIRs, the diamond, it shines. So this is the property, the shining property is totally based upon the shape how the diamond has been cut. Okay, जो ज्यादा शाइन करेगा उसमें ज्यादा टोटल इंटरनल रिफ्लेक्शन हो रहा है, इतनी सी बात है. Got it? So this is a second property. Then the third property is that diamond is bad conductor of electricity. Diamond is bad conductor of electricity. So these properties in detail I will tell you with the help of structure of diamond. Okay, अभी shining वाली property का पता चल गया. Shining property, you got to know that why diamond shines or not, right? Because of the multiple total internal reflection which is happening once a light enters. If it try to comes out, then what is happening? Then it is not able to come out because of the angle of incidence there, it becomes more than the critical angle and total internal reflection is happening. So now I will tell some properties with respect to graphite. And then why diamond or the graphite it shows those type of properties, that I will tell you, जो कि तुम्हें कहीं पे भी सीखने को नहीं मिलेगा, neither in your books or in any of the videos. So that thing should be very very clear. Okay, ये जो चीजें मैं बताने वाला हूँ ये बिल्कुल ध्यान से सुनना है. You have to listen it very carefully because these things you will never find anywhere in any book, okay, or in any videos also. Because there they only confine your syllabus up to class 10th level, class 10 NCERT level तक होता है, उससे ऊपर का syllabus होता नहीं है. So that is why you will never get to know these things. But I am telling you these things. So you have to listen to me very, very carefully. Now the case is, if I talk for graphite, ग्रेफाइट वो पेंसिल के अंदर जो लीड होती है ना, दैट इज ग्रेफाइट ओनली. सो ग्रेफाइट इज वेरी सॉफ्ट. ओके, लाइक व्हेन यू टच इट और यू राइट समथिंग, it gets rubbed, right? So that is very soft. Or the second property is that it is a good conductor of electricity. It is good conductor of electricity. Third property is it is dark. Third property is it is dark also, right? Dark hota hai. It do not shine. So I can say that it do not shines like diamond. है ना, shine नहीं करता है. So that is the case. It is also used as lubricant. It is having lubricacy. So these are the 3-4 properties of graphite which are quite different than diamond. Diamond, the same, the metal, the non-metal is same, carbon, right? It is a allotropic form of carbon, diamond. That is hard. Now the next allotropic form, graphite, if I am taking it, it is very soft. It is also good conductor of electricity, which diamond is not. It is dark. It do not shine. But diamond shines, and it is also used as lubricant. Now, what properties, what are the features which makes graphite to show these all properties? Okay, what are the features? What is the reason? And the reason is the shape, guys. Okay, the reason is their shape or structure. Shape or structure, that is the only simple reason to it. इसके अलावा कोई भी reason नहीं है. And that thing I will tell you with the help of hybridization. Okay, like in class 9th 10th you have studied like this way: K shell, L shell, M shell and N shell, right? Also the students who know the electronic configuration with respect to s, p, d and f orbitals, right? These are the modern electronic configuration with respect to s, p and d, sp, d and f orbitals. So hybridization is defined with respect to modern theory. Okay, modern wave quantum mechanics theory of atomic orbital. So s, p, d and f, and I will tell you with the help of hybridization. So you all know that whenever it is a tetrahedral carbon, its hybridization is sp3, and when there is a trigonal planar, okay, when it is a trigonal planar carbon, it is sp2. मतलब अभी तक तुम लोगों को बस ये पता है कि अगर मेरे पास सिर्फ सिंगल बॉन्ड है, okay, if it is having only single bonds, then it shows sp3 hybridization, and if carbon is having double bonds, then it is having sp2 hybridization. ठीक है, अभी इतना पता है, right? Now I will tell you the properties of diamond and graphite with the help of this thing, sp3 and sp2, means single bond and the double bond case. Now students, for the properties of diamond and graphite, if I say, you should know that in diamond the carbon is sp3 hybridized, means the carbon is attached to 4 carbon atoms. Okay, 4 carbon atoms से attach होता है, and that is something like this. Okay, so this type the chain goes on. Okay, this type the chain it goes on, and my diamond it is attached with four. In the carbon in diamond it is attached with four different carbon atoms. Okay, while in the case of graphite, my carbon is sp2 hybridized. My carbon is sp2 hybridized. That means there is a lone pair there, and the shape it looks like this. Okay, the shape it looks like that. So this is the shape of diamond, and this is the shape of graphite. Diamond and graphite. So if I see the two shapes, the only thing, the difference is single bond and double bond. Okay, the difference is सिंगल बॉन्ड एंड डबल बॉन्ड. और कोई डिफरेंस है? और कोई डिफरेंस नहीं है. सिंगल बॉन्ड है, एक में डबल बॉन्ड है. ओके, दैट इज द ओनली डिफरेंस. ग्रेफाइट का स्ट्रक्चर इफ यू आर नॉट एबल टू सी, देन मैं यहां पे ड्रॉ कर देता हूं. इट इज लाइक दिस. Okay, so it goes on like this. This is the structure of graphite. So there is a double bond, and double bond कैसे present है? Double bond are in conjugation. Double bond are in conjugation. Conjugation का क्या मतलब है? That this double bond it can move over here. This double bond can move over here. So that whenever there is a pi bond, always remember whenever there is a pi bond means whenever there is a double bond. And this is in conjugation. Conjugation means what? Alternate. Okay, एक के बाद एक. Like conjugation का मैं simple सा तुमको example देता हूँ. तो it is like this: C single bond, then C double bond, C single bond, then C double bond, like this. This is called conjugation. This is called conjugated system. इसको क्या बोलते हैं हम लोग? Conjugated system बोलते हैं. Right? So they here are in conjugation. They here are in conjugation. That means they are delocalized electrons. Okay, they are delocalized electrons. They are known as delocalized electrons. And whenever I say that my double bonds, the electrons of the double bonds they cannot move, उसको मैं क्या बोलता हूँ? Localized electrons. उसको मैं क्या बोलता हूँ? Localized electron. So the movement of these delocalized electrons here in the structure, this gives the property that it can behave like a good conductor of electricity. Electricity का क्या मतलब है? सिंपल सा, it simply means the flow of electrons. Right? Electric current means what? Flow of electrons, flow of charges, right? So that is flow of electrons. So here in the delocalized system of graphite, I have flow of electrons, which is not possible over here, which is not possible in the diamond case. So here comes the property of electronic conduction of graphite in comparison to diamond. So that is why we say that graphite they are more conductor of electricity as compared to diamond. इसलिए हम लोग ऐसी बात बोलते हैं. Now come to the next property, that why my diamond is hard and why my graphite is soft. उस पे आते हैं, है ना? That is also a good question. So when I see these two structures, then this is a sp3 hybridized, right? Means this will be a 3D case. This will be a 3-dimensional case. 3D means कैसे? Like suppose here this carbon is attached to this and this. Okay, 1, 2, 3. So 4 more, right? 1, C, 4. Every carbon it will be attached to 1, 2, 3, 4 more. Right, so 4 कार्बन से अटैच होना चाहिए every carbon. So here also will be like this. Okay, 4 carbon से अटैच होने in diamond. But the 4 carbon, 2 are in the plane of it. One is above the plane, okay, which I draw by this wedge, and one is below the plane, so which I draw by a dash. Right, this is called wedge and dash structure. एक कार्बन above the plane होता है, एक कार्बन below the plane होता है. So this is a 3-dimensional geometry. This is a 3-dimensional geometry, that diamond case. And if I talk of this, it is a sp2 hybridized. It is a trigonal planar. It is a planar geometry, right? It is a planar geometry. So that is why if I say diamond and graphite, then in the diamond case I am having 3-dimensional geometry, and in the graphite case I am having planar geometry. Okay, 2-dimensional planar. अब 3-dimensional planar से होता क्या है, that this is a 3D structure, so this is more compact. This is more compact. But graphite क्या होगा? It will be just like a sheet. ये क्या होगा? This will be just like a sheet. Means एक plane इसका ये हो गया graphite का. Yeah, the next plane will be this. One plane I am talking, right? One plane means ये जो structure अभी draw किया था graphite का, that उसको हम एक plane बोल सकते हैं. Similar molecules अगर फिर से combine होते हैं, they will give me a next plane. Similar molecules फिर से combine होते हैं, they will give me a third next plane, right? So graphite के case में I am having layer wise structure. Okay, the structure is layer wise. Means I am having one layer, then next layer, then next layer. But diamond के केस में ऐसा नहीं है. Diamond के केस में it is all 3-dimensional. It is a more compact solid structure, and that is why it is the hardest material. Okay, and यहाँ पे as this is a planar structure and it is a layer wise, so the layers they can flow over each other, right? The layers they can flow over each other because of the delocalization of the electrons there. And if that happens, then what will happen? That it is become a good lubricant, okay, and soft as well. Lubricant and soft वाली property clear है? It is a layer wise structure, and that layers में क्या है? I said delocalization of electrons, जो दिखाया था अभी यहाँ पे, right? That is a delocalization of electrons, and due to which it will be a lubricant and soft thing. And diamond is the hardest thing. Diamond shine क्यों करता है पता चल गया? Because of the total internal reflection. Because of total internal reflection. And if I talk of graphite, why graphite is dark? मतलब graphite क्यों? मतलब it cannot show me the TIR. Why graphite cannot show me TIR? Because the electrons there in the conjugation, they are free to move. So whenever this I am roughing it, okay. These properties are clear, I guess, to all of you. Now if I check for graphite, then in graphite I have a set of something called delocalized electrons. So whenever you will pass any light to it, any light to my graphite, then what will happen? The delocalized electrons, they will absorb all the photons. Photons means what? The light particles, है Graphite, if you pass light to it, if you provide light to it, it will absorb all the photons. और कोई भी चीज अगर absorb करती है हर वेवलेंथ को, हर लाइट को, then उसका कलर कैसा हो जाता है? डार्क हो जाता है. उसका कलर डार्क हो जाता है, right? For example, if I say white color, that means it is reflecting all the light, whatever is coming on it. If I say dark, black body radiation, black body. So black body is like what? Anything which can absorb all the light. That is my black body. So my graphite is, because of the delocalized electrons are present there, right? Which is not in the case of diamond. So the delocalized electrons which are present in graphite, they have the obviously they are free, right? So they can absorb this light, and that is why they are a bit dark. That is why your graphite structure is bit dark. So this was the important thing which with the help of structure you should know. बस ऐसे rectification के लिए नहीं, but with the help of structure you should know that why graphite and diamond, the allotropes, although they are of the same non-metal, but they show different properties, right? Why is it so? So it's basically all because of the structure. Structure of diamond is like 3D structure. It is a sp3 hybridized, single bond only. And in case of graphite, it is a double bond. So therefore it will be having some delocalization in it. To be having some delocalization in it, and due to which it shows electrical conduction property. It shows my the darkness property, absorption of light. It also shows my lubricant property. It is soft also. So these all are the properties of diamond and graphite with respect to structure. With respect to structure. So this was the main aim of my video, to make you feel that what is the information you should require when you enter in the higher classes. Okay, these information will not be in your simple textbooks or up to class level, any of the book. You will not find these all information, but you should know this, because this is very easy. And the thing is, you will be on a side of, let's say, you'll be benefited more. Okay, you'll be having a lot of benefits in the higher classes, because you have not ratified it, but you have studied it with a good grasp. Okay, with some concept, with some funda, that why do these show these all properties, and mind yet you will be more confident also, and you will love organic chemistry while you will be learning it in higher classes. So that's it. I hope it was very informative, and you please make good notes of it, because that's very required in higher classes. Up to class 10th in your boards it will not be that much important, but in higher classes it is very, very important. So make good notes of it, and try to always, it's right now I've only told you about the allotropic form, right? Now in many chapters there will be something different stuffs. So always try to find why in it. I'm again and again telling you, why is very, very important. If you just say that okay, it is just written, ये तो लिखा हुआ है, इसको ऐसे ही बस रट लेना है, तो you will never succeed. Try to get the reason why it is written like this, why it is showing like property like this. Okay? Fine. So I hope you must have got the basic difference between diamond and graphite.